let's see what I did. Questions off page 25.
Unit 6.
Yes, ma'am. Number 6. Yeah, x plus 5 quantity squared. This one?
Yeah.
Alright, that's the same thing as x plus 5, x plus 5. Is that okay? And then we do our shortcut. First number squared, last number squared. Multiply here, and double it. Done. Is that okay? What other questions did you come across? Good? Everyone happy? And again, if you don't see the pattern right away, you can always just do it this way. It's totally fine as well. And then combine your like terms. I don't think the shortcut saves you a whole lot of time, so we don't worry too much about it. Cool? All right, if you would, make sure your name is on your assignment. And if you're turning anything else in, make sure your name is on that as well. Hand it on forward, please. Yeah, boy. Oh, come back for yours. Yeah. Thank you. All right. Get your notes out.
I just made it. First try. Kobe. That's all back. You're a bum. I'm not. You're a bum. That's how this conversation is.
Are we gonna have a quiz on this?
She got mad at me.
Yeah. I mean, I'll have probably another quiz sometime this week, a small one.
Like the half sheet thing?
Yeah. Everyone got some notes? We're good? All right. So let's just warm up with this. So on this first one, I multiply that here, here, and here, right? Is that okay? And today we're actually going to go backwards. We're going to go from the green back up to the original. So we'll start factoring. Second one, 2x minus 7, 2x plus 7. What are those called? Starts with a C. Has conjugates in the middle. Conjugates, right? So if I have difference of two squares, if I have the exact same binomial separated by two different signs, your shortcut is this. Done. Where did the middle terms go? Well, they went away because I'd have positive 14x, negative 14x, right? Mm-hmm. Number 3, they're the exact same binomial, so we could do the sum of, we know that our perfect square one, so you get 9x squared, last number is plus 4, multiply those, 6, double it, or you could have just multiplied the whole thing out. And then if they are just completely different, then we just have to multiply them all out. So I get 12x squared plus 42x minus 10x minus 35. Combine like terms. Plus 32x. Is that okay? Any questions on any of those? So sometimes you're just distributing something to everything. Sometimes you have difference of two squares where you have two different conjugates of each other, same binomials, one sign off. The middle terms go away. Sometimes you have the perfect square trinomial, and then sometimes you just have to multiply everything out. Yay? Ready to move? Yeah.
Okay. So here on 2 and 4, could you do the short version? Like
I did the short version up there, but you want to do the long version?
No, like I'm saying, okay, so like for 4, did you do the short?
No, because everything's different. There's not really a short. So you have to go this times this times this, and then this and this. Is that okay? And then 3 you totally can because it's going to be perfect square. Is that okay? Did I answer your question? Yes.
So 3, you do the same, like you do that specific like shortcut because all the numbers are the same.
Yeah. I mean, you don't have to. You could have made this 9x squared plus 6x plus 6x plus 4. And then plus 4, and then it combines that. I don't even know if the perfect square trinomial is a fast shortcut. I don't think it is.
Okay.
It's like it saves you like a micron in a second. Which is one more thing to remember. We good? Okay. Let's see what this next thing's got. All right, factor. To write a product of 2 or more terms. So if we were to like take the number 6 and factor it, we could have 2 times 3, right? So factors of 6 are 2 and 3. GCF, which is the greatest common factor, this focuses on when we have like a whole spread of numbers and letters and polynomials. Greatest common factor could be a number, it could be letters. It's what all the terms have in common. Okay? I'm sorry, I'm sucking snot so much right now. Good? That all makes sense, okay? Or we'll be working with that a little bit more here in a moment. All right, so what do they have in common? Picnic, card, and pool. Picnic, card, and pool. What do they have in common? They're all tables. Picnic table, card table, pool table. Ooh. Egg, safe, and whip. Yeah.
They all can be cracked.
Oh, love it. I don't know why that I think it's they all can be cracked. I don't know why we have the y'all can be cracked, but good. See? You're gonna ace this stuff. All right.
You know it says it on paper, right?
Huh?
It like says it on paper.
Oh, it's all on paper. Okay. Shucks. I thought you were on this. I mean, you could have just, led me on, and I would have thought you were real smart. All right. I do think you're smart. I want to look at 2x plus 8. And so things I want to think about on this problem are, I know 2x is 2 and x, and I know 8 is 2 times 2 times 2. Now let me just pause there a minute. Do you agree that 8 is 2 times 4? I hope so. And then 4 is 2 times 2. So do you agree that 2 times 2 times 2 is 8? Is that okay? You're not too far fetched. So I have up here, this is a binomial. I have 2 terms. I have a 2 and a 2 in common on both. Agree? Anyone like, I don't see that. So what I can do is I'm going to undo it. I'm going to factor it. So this is going to turn into 2, because they have that in common. And then what do I have left right here if I factor 2 out of 2 and x? So what's left if I factor 2 out? X plus, what do I have left here? 2 times 2, which is? 4. Okay. You just took your first step of factoring. They have the greatest common factor. They both had a 2 in common on both of the terms, because 2 times x is 2x, and 2 times 2 times 2 is 8. So if I redistributed that, if I went 2 times x, I'd get 2x. If I went 2 times 4, I'd get 8. Seem okay so far? So what about number 2? What does it look like I might have in common between those 2 terms? Well, 3x is 3 times x. 12 is the same thing as 2 times 6, or 3 times 4. Which one would be better used, 2 times 6 or 3 times 4?
3 times 4.
Why is that?
Because it's 3.
You already have a 3. So I have a 3 and an x, and a 3 and a 4. And I guess I can make the 4 2 times 2 if you wanted me to. So let's factor out. I have a 3 and a 3. Bless you. Let's factor that out. If I factor a 3 out of 3x, what do I have left?
X.
X.
Plus
The minus sign comes down, right? Because it was minus. What do I have left here?
Well,
minus
Huh?
4.
4. Done. And again, if you distributed 3 times x, you'd get 3x, and 3 times negative 4 is negative 12. Yeah.
What if there isn't like a common?
Then it's already in its factored form. All right, what about number 3? X squared is the same thing as x times x, I think. Is that okay? And then 5 times x. Let's see what we have in common between these two. I have an x and I have an x. Do you agree? Let's take a look at it. So if I factor an x out, if I factor an x out of x squared, what do I have left? X. The plus sign comes along for a little ride. If I factor an x out of 5x, what do I have left?
5.
Done. Number 4, can you see a greatest common factor as it sits? I have 3xy as one term. I have 2y for another term. What do I have in common between the two?
Y.
I have a y in common. Do you agree?
Yeah.
So if I factor a y out, if I factor a y out of 3xy, what do I have left?
3x.
3x. Plus comes down. So if I factor y out of 2y, I have left
2.
Done. You just took your first stab in the dark on factoring. This is when we have a common factor. All right? Seem okay? The thing is, if you take your time on these, you're going to get through them very easily. If you think, oh, I'm just going to wing it, it might goof you up. All right. I think these are the last ones. We'll, oh, 2 more. Okay. So problem number 5. Let's make this. Do you agree with what I have written up there? Or am I missing anything?
Missing the 4.
Yeah, I'm missing. So 2 times 2 is 4. So 2xx is the same thing as 4x squared, and then 2 times x. So what do I have in common here?
X.
X, definitely.
And 2.
And a 2. Okay, so I'm going to factor a 2x out. And then if I factor a 2x out of 2xx, what do I have left?
2x.
2x. The minus sign comes down. If I factor 2x out of 2x, what do I have to put as a placeholder?
0.
If I put a 0, 2
1.
times 0 is
1.
0. But a 1 would allow that. So good thinking,
Where
you
did
guys.
you get that 2x?
Okay, this 2x right here. This right here.
No, we didn't.
Or this one. So I have a 2 and a 2 in common on both. I have an x and an x in common on both. What do I have left here if I factor a 2 and an x out? I have this 2x left there.
2.
See the 2 right here? Because 2 times 2 is 4. So if I multiply 2x times 2x, I'd get 4x squared. If I multiply 2x times negative 1, I get negative 2x. So this is the factored form. It's broken down. We did the reciprocal property of it. Number 6. I have 2x to the third minus 4x squared minus 8x. So let's break this down into its smallest parts. So 2x to the third is 2x, x, x. Is that okay? Bring the subtraction. 4 is the same thing as 2 times 2. And then x squared is xx. And then 8 is the same thing as 2 times 4. 4 is the same thing as 2 times 2. And I have an x right there. So let's see what we have in common between these. I have a 2. I have a 2. I have a 2. Is there any more numbers that all three have in common? Numbers, not letters. No? Then I have a single x, and another single x. Can I factor a second x out of all three terms?
Yeah.
Look here, I have a 2 and an x already coming out. Is there still 2x left or an x on this one?
No.
Nope. Okay, so I'm factoring out a 2x, parentheses. Let's see, what do I have left if I factor a 2x out of 2x, x, x?
X squared.
X squared, good. Okay, the minus sign comes down. What if I factor a 2x out of 2x, x? What do I have left?
2x.
2x. The minus comes down. If I factor a 2x out of 2x, what do I have left?
4.
Done. So let's verify this would work. If I were to go 2x times x squared, do I get 2x to the third?
Yeah.
Yeah. If I multiply 2x times negative 2x, do I get negative 4x squared? Yep. If I multiply 2x times negative 4, do I get negative 8x? Yeah. Cool. Seem okay so far? So if you take the time to break them down, you're going to probably see the answers pretty easily. All right, 3 won't break down any further, but I get 3x, x, y, y, plus 2 times 3, x, y, y. All right, do I have a 2 in common on both? No. Do I have a 3 in common on both?
Yes.
Yeah. Do I have an x common on both?
Yeah.
Yeah. Do I have another x common on both?
No.
No. Do I have a y on both?
Yeah.
Do I have another y on both?
Yeah.
Yeah. So I have 3 times x times y times y. 3 times x times y is 3xy squared, parentheses. What do I have left if I factor a 3xy squared out of this first?
X plus.
X plus, what do I have
2.
left? 2? I totally agree. So again, if I were to multiply this back over, if I redistributed it, I'd get 3x squared y squared plus 6xy squared. And it would work out nicely. What do you think? We do it slow enough and gradual enough, you're going to get it correct. Can I move off the slide, or is anyone still writing anything down? You good?
Yeah.
Okay.
Then.
Brett?
What?
All right. Ooh, okay, this is a little different. So let's look at this. Do I have something that both have in common with in parentheses? I do. So I have this and I have this. So if I factor an x minus 2 out, if I factor an x minus 2 out of this, I'm left with x. If I factor out here, I'm left with a plus 5. Done. What do you think on that last one? Can I factor out on one?
X squared, since there's 2 x's.
Where are you looking?
Remember like the x minus 2?
X minus 2?
Yeah.
So I had it in common on both, so I just drew it out, and then what I had left.
Okay.
Now let's look at this one. I'm going to do the same thing. I'm taking x plus 3 out. What do I have left if I pull an x plus 3 out of here? 4 minus, what do I have left here?
X squared.
X squared. Now, if you got to that point right now in this class, you're awesome. This right here will actually break down a little bit further. So this is like 100 million extra credit points if you can make it like this. But if you can get to this point, I am happy. But this point is like varsity math. If you don't get to that point yet, you're fine. Cool? We good? That's it? Can I give you the opportunity to start it?
Yes.
Cool. All right, we're going to do page 2728. Cool? You got plenty of time, so let's get a good start on it. Ask me if you have questions. Don't get stuck on it. Let me just get this video start saving so our friends at home can watch it.